So it's 11 o'clock, at least here where I'm living. We will start the presentation Tecplot data format. Hello, good morning and good afternoon wherever you are, in which time zone. Welcome to the Tecplot webinar on the Tecplot data format. My name is Martin Rössler and I'm of Genius Graphics. We are a distributor of Tecplot in Europe. This webinar addresses people who export their data in Tecplot data format from their own code in order to put them to visualize the data in one step in Tecplot. I will go through parts of the data format, showing you format options, format components, using an ASCII dataset, a simple ASCII dataset, so it's pretty easy, should be pretty easy to follow what I'm doing. And just allow me to a few words about Genius Graphics. What are we doing? We are the Tecplot distributor for Europe, and we are doing this for a pretty long time, for about 14 years. So the customer base is pretty broad. We have about 2,500 customers. The users are of course a little bit more because when we take into account the network licenses, then the users are higher. We are located in Germany, near Regensburg in the southern part of Germany, and we're not only doing distribution of the software, but we're also giving training and we're doing projects. That means if a customer needs a special evaluation or some specific representation, we can help him by doing this on a project basis. And of course, we are giving you support for Tecplot products. A few technical hints. All of the attendees, all of the participants are muted. So this has the advantage that we don't have any background noises or echoes on the line. I think for everyone it should be a clear line. That doesn't mean that you can't pose any questions. You have the possibility to use the chat dialog in your GoToWebinar dialog, or always you can give me a call or send me an email to support@tecplot.de after the session. I would propose that we shift the time for questions at the end of this presentation. So, what is it in detail what we are talking about here today? You have your own code and you would like to export your data. So there are some format components which you can use in order to make your work easier within Tecplot. So for example, if you have transient data, you don't have to use the strand editor, for example, to make a transient data set of your data, of your zones within Tecplot manually, but you can make provision in the output already for the transient nature of the data set. Then if you have taken that into account, you can also use this for time series plots, animations, which take time changes into account. And you can also put some so-called auxiliary data or metadata into your data set. These are, for example, constants or variables which indicate what you would like to use for velocity variables, for example, for the Tecplot analyzer. And you can use this additional input in order to give information about the data set created in the solver to Tecplot. For example, put some texts on it, like what kind of computation was it, which solver did you use, what time and date was the data set created, and so on. We will see this later on. So then I suggest I start by starting Tecplot, and I would like to create here just a simple data set. That means I'm creating in the beginning an ordered zone, but a rectangular zone which consists of only 4 nodes. And for the procedure following, I would like to transform this ordered zone into 2 triangles using the triangulation feature of Tecplot. When I turn on the mesh, I see we have 2 triangles, and go to Data, Dataset Info, and there you also see a triangulation with 2 triangles. So let me take away the first zone, we no longer need it. Then in the next step, I will define 2 variables using the equations dialog. So the first one is putting some stress on it, and I would like to be stress a cell-centered variable. So I'm changing here to new variable location to cell center, compute it, and my next variable should be pressure, giving it also a constant variable of 20 for this zone, and pressure should be defined at the nodes. So I'm changing here to new var location to node and compute. So here we see our 2 new variables. I'm clicking on it and see it's cell-centered for stress and nodal for pressure. To show you what you have to do when you use the strand editor in order to make a transient dataset from the zones, what we would like to avoid by outputting the right format components from the code. I'm duplicating here this zone a few times and go to Dataset Info in order to, well, make the name a little bit shorter. And okay, here we go. We see here in the zone style dialog that we have 4 zones. One moment please, just 1 short second please. Okay, I'm back again, thank you. Well, we have 4 zones now, and I would like to create a transient dataset out of this zone. And how do I do this? I go to Data, Edit Time Strands, and here I have the possibility to assign a so-called strand ID to these zones. A strand ID of 0 means a zone is treated as stationary, as a non-transient zone. Yeah. Using strands means you are building a set of zones which represent the same part at different time steps. So let's do this. I'm assigning a strand ID of 1, and solution time should be starting from 0 with a delta of 1. And now take a look at the zone style dialog, and then you see that we have here an asterisk in front after the number and after the name. That means we have a transient dataset. So in order to make them visible now, currently all 4 zones are lying on top of each other. So I would like to add additionally shift to the x variable in order to place them side by side. So just one after the other. So when I now change the time step, you see that we get 4 zones which are moving from left to right. Now let's take a look into the ASCII dataset for this dataset in order to see the format components we are using. Let's go to File, Write Data, and I'm putting it out as an ASCII file, of course, and we don't have the chance here to choose between point or block format, because we have defined stress variable as cell-centered. If there is a one cell-centered variable in the dataset, it just can't use block format. So we have 4 bodies, and let's take a look here into the dataset. 4 bodies, and what we see here are different entries in the dataset. So the first 4 lines here is the so-called file header. It starts with title, of course. You can put some other information here. Then you have the variable names, and then you see here, this is our first zone, body 1, and we have here strand ID 1, which means this is a transient zone at solution time 0. It's an FE triangle zone consisting of 2 elements. We have data packaging block, and variable 3, our stress variable, is cell-centered. Then you see here the data type line. That means this is the possibility to tell Tecplot the precision of the data you have. And well, in the next step you see the data itself. As we have data packaging block, that means first the all x variables, then all values for y, all values, which are only 2 here because it's cell-centered, for stress, and the values for pressure. As we have finite elements here, triangles, we need to have a so-called connectivity list, which is placed at the end here. This is the connectivity list for the 2 triangles. Now let's take a look at the 2 remaining zones. We also see here strand ID of 1 with a different solution time for each. But we see here another thing, it's the so-called variable share list. The only thing which is different from zone to zone is the variable x, because I have put a placement on x. All the other variables are equal to the first zone. So it's to the first zone. So the variables 2 to 4 have the same value as the variables for zone 1. This is a possibility for you to reduce the amount of data when you create your own Tecplot files in your solver. For example, if you have a transient data set and the grid doesn't change over time, then you can refer to XYZ from, let me say, zone 1, which contains the grid, and you need not specify it every time within each zone. You can also make a reference to the connectivity list of the grid. That means you have here connectivity list, connectivity share zone equals 1, and then this line here, this is specific to body 2 and to all other bodies up to the first one. This is the x variable values for each zone, and this is repeated for every zone following. So I have showed you here an example which contains just one strand ID. So you see that with each time step the 2 elements are moving. I'm giving you another example using some more strand IDs. First I will change the names here and go back to the strand editor, and here I can tell Tecplot, listen, use multiple zones per time step. That means I have now 2 bodies per time step, and start using time strand 1, and then we see here in the zone style dialog that we get 2 zones, 2 transient zones. And well, if I change the time step, you see that both are moving, and the difference is only the value in the strand ID. So let's take a short look into this here, into this data set, strand ID equals 1 and strand ID equals 2. That's the trick. So we have set up two sets of zones which represent the same part at different solution time. As a next step, I would like to create a zone in the same data set which is considered to be non-transient, so something like a control line consisting of some points. I'm doing this by data create zone O1D line from 2, 4, and let me use 10 points. So this is our line here, and let me put some scattering on in order to see the line a little bit better here, how it changes. So, okay, so the line doesn't change here, and it's a non-transient line. So let me write out this new data set. And let's take a look into this new data set. And what we see here is that we have this different strand IDs, but we got one additional zone at the end which has a strand ID of 0. That means it's non-transient. And as each zone in one Tecplot file, one Tecplot data file, has to have the same number of variables, we also get here 4 variables, but we don't need variable number 3 and 4. We just need its position. So we only need x and y. And well, if you have a long line in the data set and you have multiple or lots of variables, you will fill the zone definition for the line with zeros. This can increase the size of your file, and you can avoid this by taking away the definitions for the last 2 variables and introduce something like a passive var list format component, and then you specify the variable numbers for those variables which are so-called passive, and I'm also taking away these 4 variables, these 2. So now let's load this dataset into Tecplot. I'm opening a new frame for this using the quick macro panel and creating a new page. It says defining it as passive file load data. So that's the line dot. Turning on mesh to see the line, and now you see the line as well, but you have reduced the size of your file. And when you go for probing this line, the 2 variables which I have set to passive always return a value of 0. Keep this in mind. So we have learned 2 possibilities to reduce the file size. It's passive var list and variable share list, and also a third one, connectivity share list. Okay, let's take a short look back to the presentation here. Well, we have talked about the file header. We just missed one thing, the file type. I will get back to this. Then we talked about block nodal, block cell-centered, point nodal, and so on. And what we will talk about as well is these auxiliary data records available for the dataset and for the variables, and well, for the zones also. So far we have assumed that all time steps for a transient dataset are included within a single file. but you probably will have one time step, one file. In order to avoid the grid definition in the beginning of each file and thus creating lots of memory, there is a possibility to write out the grid separately and the solution files for each time step separately. Well, let me show you the grid file. I have an example here. The grid file, this file contains only the grid by putting in a file type equals grid. If this file type component is missing, then Tecplot is always assuming that the file contains grid and solution. And then you would have, of course, additional files which represent the solution, and here you have the format component file type set to solution. So how do you load these files? When you would like to load these files, you are using the Tecplot loader and open the multiple files option. So this you can do, file, load data files, Tecplot, replace, and then you open the multiple files section. The order you are specifying the variables to be loaded decides about which grid is used. For example, I have a grid here, I add it to the selected files list, then you have, for example, this solution files which refer to the first grid. In the next step you're specifying the second grid you have and, for example, the solution file which refers to the second grid. That's the way you would like to load a transient data set which consists of multiple files. Okay, there is a mismatch between the names, not a problem here. I'm going back to the editor and showing you again, well, you have file type solution here and grid. That's the main thing you will have to take into consideration, and I have also put it here into the slide. So if the geometry is not changing, just place grid 1 on the first line of the multiple files dialog and then all the subsequent solutions. If the geometry is changing, make sure that you have the different grids at the corresponding position and then place the corresponding solution files immediately after the grid. So this is not yet the end. I would like to talk about something else now, about the auxiliary data for the dataset and the variables. The auxiliary data allows you to put additional information into the dataset. I have prepared one dataset here. So what you see here is a small dataset which contains 5 variables: x, y, my u, my v, and pressure. Then we have here a so-called dataset aux data section. Here we have some names which start with common. These are keywords. So using these common keywords with these variable values tells Tecplot, well, okay, I have found these keywords. I can make the analyzer, the Tecplot analyzer, use the values of these format keywords to preset the analyzer settings. And then you can also use the dataset aux data format option to give the dataset additional information which you can use, for example, in a style sheet or in a layout to make this additional information visible. This is very good if you think of automizing your work. Then the next step, the next section here is a variable aux data section. The number here refers to the number of the variable from 1 to the end. And that's just a short example. You can pass the unit for declarative purpose, for example, for putting it on in a text object on the frame. And I will show you what the thing looks like by creating a new page, calling it aux data. And I will load this data set into Tecplot. And I've also already prepared a so-called style sheet. Well, a style sheet allows to, for dynamic text, allows you to put a predefined view, to place predefined texts onto the frame by load frame style dynamic text sheet. So here you see at one glance all the texts are created with the corresponding values of the dataset aux data and var aux data variables. So what's behind each text field here? Let me double click it and, well, just let me copy it. So you see here, this is a so-called dynamic text. It starts with an ampersand. This is an identification for a dynamic text. And then you see here the aux data set reference to the name, organization or department, and these references are replaced by their value in the dataset. And the same applies when you take a look here to this text. You see here, just let me copy it as well to this sheet. You see here that this is text entered, and then we have the ampersand, which indicates your reference in here, the aux variable number 3, and the name of the variable aux data is unit, and, well, replace it. That's it. That's all. It's a good means to reduce the work for placing texts on the frame. Well, my recommendation is output as much information as you need into the Tecplot file, and then use a style sheet, or you can also use it within a layout file to place your information onto the frame. That's just one purpose. The other purpose I mentioned is the presettings for the analyzer. When you go to the analyze entry here, the analyzer requires that some of the variables are set in order to be able to calculate variables, to extract flow features like vortex calls and so on. So before you use the analyzer and its functions, you are required to set here, for example, the field variables. And as I was using these, let me go back, these common entries here, common reference Mach number, common vector variables R velocity, and common UVAR and VVAR, we see that my variable names, my U and my V, have been taken for velocity automatically by Tecplot. And also when I go to reference values here, you see the Mach number here is set to 0.82, which is what I have defined here in the dataset. So when you create your own files, when you have the chance, you have lots of possibilities to take influence in how you can make your work easier, or in reducing the file size. If you would like to get more information about the data format, if you have specific questions, take a look in the data format, or give me a call, or write me an email. We have talked about ASCII data sets so far, well, because they are much more easier to present and to get a notion of what it's all about. When you have created ASCII files, but you would like to load binary files, which I would recommend because of the reduced file size, there is a utility called Tecplot. Tecplot is located in the installation directory of your Tecplot installation in the subdirectory /bin. So look for Tecplot. It's converting ASCII to binary. The better option would be perhaps to output binary format right away from the code. And there is a so-called TecIO library which allows you to use this interface and to create binary files. The library is already installed with the distribution. I'm sorry. You can find it on Linux, Unix, Mac, and so on. In the lib directory, it's called TecIOA, and on Windows you have the bin TecIO lib, and for both platforms you have the header files in the include directory. For those who would like to download the Tech.io again, you see the link below at downloadtecplot.com. A word on the Tech.io interface. In the manual you will find this function calling sequence. I recommend to take a look at this sequence, because when you take a look at it you will find some logical structure behind it. So what do you have to do for each zone, for example? What do you have? So you have to define the zone, put the data, put the nodes, and so on into the loop, and this gives you better entry into the whole topic. So this function calling sequence, I think, is a good graphical composition of what has to be done by when you would like to create your binary files directly from the solver. So just let me take a look if I have missed something so far. No. If you have questions regarding the Tecplot data format or Tecplot and its functionalities, so you can always send us an email to support@tecplot.de or give us a call. We are using this tool we are using now, GoToMeeting, for support purposes as well. And there is also a possibility to use new add-ons. If you go to Tecplot Talk, there you will find additional features. Okay, so thank you for taking part in the presentation. We are at the end now. If there are no more questions, if you have questions,